Welcome to Pepperl+Fuchs Plugged In, where automation professionals can stay in touch with the latest enhancements in sensing, data communication, and control.
Hello and welcome everybody to today's episode of Pepperl+Fuchs Plugged In. And I have again Cory Ockunzzi with me. Hello, Cory.
Hello, Helge. How are you doing today?
Doing just fine, Cory. Thanks for asking. Cory, this is now, I don't know how many times we have recorded something on some of your products, but you have another one which I thought was particularly interesting because it carries the name fusion in the name, or the term fusion.
That's correct. It's our IMU, which is an Inertial Measurement Unit. And it's the same one that we launched a year ago with the J1939 output, but now this version has a CANopen interface.
Whoa. You're assuming that everybody just willy-nilly understands and knows what we've been talking about a year ago. So why don't you give us a little bit of an overview of what this product is intended to do?
So an IMU is intended to calculate angles and also rotational speed, but it also uses that fusion software that you mentioned to filter out any external acceleration. So these would be what we call dynamic applications, where the entire machine is moving or accelerating in different directions while you're trying to calculate the angle of an arm or a bucket or some other type of implement that comes off of that machinery.
Everything you've mentioned, and I think we should make this very clear, you were referring to equipment like trucks and earth-moving equipment and maybe big mowers that need to mow along an incline, essentially mobile equipment type products.
That's correct.
And the intention, I think, is to make sure that this equipment does not get into a situation where it could tip over. That's probably one of the main applications.
Yeah, one of the main applications is safety, because as you mentioned, you can have a mower or maybe a tree trimming piece of equipment that can be on an angle, and you want to make sure you're not putting too much weight on the downside of that angle as you're moving and have the whole machine tip over.
And incidentally, I want to share this with you. I saw not too long ago, I saw an AGV, a forklift AGV that had a unit like that, because same thing. They need to go pick up a load, and if the load is a little bit too heavy, these things could ever so slightly tip over and end up in a dangerous scenario.
That's correct. And also with the forklift, when you pick up the weight, you want to make sure that you know what the angle the forks are at as well. So as you're moving along, if you have a standard inclination sensor that's intended for a static application, which means the machinery is not moving, any kind of acceleration is going to look like the forks are either tilting up or tilting down. Where with the IMU, it'll use that fusion software to filter out the acceleration of the forklift itself while maintaining that angle to make sure that your load doesn't slip off the end of the forks.
Yeah. Excellent point, because acceleration in terms of gravity is really the same as acceleration in terms of increasing speed. So one has to be very careful not to confuse one for the other. And it's exactly that fusion algorithm that is able to separate those two out and give us reliable angle data, even in accelerated scenarios.
Correct. Yeah.
Awesome. Usually when we have these conversations, I start out asking the typical why question. Why is this important? And I think you already mentioned one part. It's safety, but that's not it, right? That's an important piece, of course, but there's more that can be done.
Correct. So if you think of something like a bulldozer, you have a bulldozer that's moving along, and you have to be able to control the angle of the blade, left, right, up and down, and of course forwards and backwards, to make sure that you're leveling out your dirt. So you would have a combination of more than one IMU on the bulldozer. One would be on the main body of the tractor. The second one would be on the blade itself. So as it's moving across the dirt, you are making sure that the blade automatically, you can set it up as an automatic adjustment to keep the blade at the correct pitch and angle as the bulldozer itself may be moving around a little bit.
And that means we're taking something that is otherwise very demanding and taxing for the operator and automate it. So the quality of the output, i.e. the flatness of the area, the flatness of the soccer field or the football field they need to work on, is going to be increased, and they can do it quicker.
Correct. And they can do it automatically. So in the past, you had the
Yeah.
user, it's very taxing, as you said, on the operator, because he has to maintain these blade angles at all times. Now it can be completely automated. So all he's basically doing is driving the bulldozer itself and making sure he's going in a straight line, and everything else is taken care of by the automation.
Okay. Okay. So let's reiterate really the benefits of what this IMU system brings to the table compared to others, including, by the way, our own angular measurement systems.
So basically, for this, you're using it in a dynamic application. So you're able to measure not just the angle of the piece of equipment itself, but whatever arm or implement that you're measuring the inclination of while it's accelerating or moving. Where if you have a static inclination sensor, the piece of equipment has to be static, not moving. We're talking like if you have a fire engine, you can measure the angle of the ladder as it goes up and down, but the fire truck itself is not moving. So there's no external acceleration that's going to give you false data on the inclination. Where if it's a wheel loader, for example, where you're picking up a scoop of dirt and you're moving along, you want to make sure that that angle of that scoop is maintained while you're hitting bumps and turning left and right and accelerating forwards and backwards, either speeding up or slowing down.
And that does bring up my next question. The types of motion that you mentioned are vastly different. A truck, let's say a garbage truck that needs to, or where the sensor would be used to measure the angle of the implement that picks up the garbage cans, it moves at a considerably different rate than a wheel loader or a bulldozer. So how do we accomplish reliable operation over such wide area, such wide set of parameters?
That's actually a new feature of this IMU. It's what we call our compensation range. Basically, there's 8 settings, and when the OEM is actually building the machine, they can do their own testing to see which setting is ideal. But in the case of a garbage truck, where you have a long acceleration down a smooth road, where you're speeding up for a while and then slowing down, speeding up and slowing down to stop and grab these garbage cans, you would have, again, 2 IMUs. One would be on the garbage truck itself. The second one would be on the forks or whatever implement is picking up those garbage cans to dump them into the garbage truck. So as you're accelerating down the road, you would have a higher compensation range, which means there's going to be a longer time delay in which that Fusion software is filtering out the acceleration. Therefore, as you're going down the street, it doesn't look like the arm of the garbage truck is moving up or down. Whereas when you have,
Okay.
if you have something like a bulldozer where you're moving very slow, but there's a lot of bumps that you're hitting, they're very short bumps or shocks, and all you're trying to do is keep that blade consistent. You don't need as much of that time. You need a lower compensation range in order to just to keep the blade in the right spot, if that makes sense.
Yeah, that makes perfect sense. In one case, you need to be more reactive. In the other case, you actually don't want to be quite so reactive. You want to filter out over longer periods of time. And I understand it's simply done by changing one number.
That's correct. And once that number is set by the manufacturer, it usually does not need to be changed by the end user. They can change it in the field. However, you have to go into like a shutdown. You have to go into like
You have to reset the sensor afterwards.
yeah, it can't be done like on the fly. It has to go like into a standby mode, and then you have to restart the sensor. So as somebody's driving, you don't have to worry about somebody operating this equipment and then just changing it as they're going down the field, down across the field.
Yeah.
That's not possible. You have to literally stop and
Yeah, that makes sense. You wouldn't want that because who knows what happens when that were to be the case. Excellent, good. So now we kind of know why we have it, what it does. Talk a little bit about the application. We always want to bring this down to the real application. So what could you come up with? What are great applications for this product?
I would say one of my favorite applications is the fact that you can tell how much dirt or how much weight you have in the bucket of, say, a wheel loader or earth mover, or I used to, when I was a kid, we called it a front end loader, where it's just a giant tractor with a big bucket on the front. And what you do is you have one IMU on the body of the tractor itself and another one on the bucket. And as you scoop the dirt, you can actually measure how much the tractor flexes, like the front suspension, how much it tilts backwards and forwards, and calculate how much weight you've just put into the bucket.
That is, yeah, that's awesome. That's of course something the machine manufacturer, the truck manufacturer can do, because they know how much their equipment weighs and what the weight distribution is, and then they can do this this math. That's very good. Okay,
Mhm.
well,
And that would help.
yeah. Sorry, Cory, go ahead.
I was just going to say that could help with things like, so you want to maximize the amount of dirt that you're putting into dump trucks as they come up and take that dirt and haul it away. Now, there's a certain limit that you can put into each dump truck. So now you know exactly how much weight you've put in there, and you're maximizing your dump truck loads, which makes the whole operation more efficient.
Mm-hmm. Good. So, Cory, the next step. I'm trying to summarize our conversation, and in the meantime, you think about our favorite 5 words takeaway from the conversation. Okay, does that sound good?
Sounds good to me.
All right, so let me give this a try. This is not going to be all that easy, because it's a fairly involved piece of equipment. So IMU, which stands for Inertial Measurement Unit, combines an inclination sensor, accelerometer, and a gyroscope to compensate angular position when equipment is in motion. So that's what it is. This particular unit is designed to be used on mobile equipment, and mobile equipment could mean earth movers, mowers, garbage trucks, anything that has a piece of implement on it, and you want to make sure that it doesn't tip over. So one of its main functions is security and safety of the operators and the people that are working around it. Another important aspect of this device is to enhance the operation, whatever needs to happen. And we talked extensively about grading a field. So when you do that, you need to keep your blade that pushes the dirt, you need to keep that in a certain orientation, irrespective of what the truck itself does. And so with this sensor, you can automate these processes and therefore relieve the operator from having to do a lot of mental calculations on the fly and do some quick manual adjustments, and therefore improve the output, improve the speed, and at the end of the day, make it a little more manageable for the operators. Cory mentioned another great application, that is weight calculation based on some basic mechanics and comparing a few measurement values from such IMU sensors. It's actually possible to determine how much a piece of earth moving equipment or other type of device is picking up. I think I want to leave it here, because it doesn't make so much sense to talk about the sensor all that much. It's really the applications that matter.
Yeah, it again, it has a wide range of applications throughout pretty much all mobile equipment. So it's a very important sensor to have if you're a mobile equipment manufacturer.
Great. Good. So, Cory, 5 words. What'd you come up with?
For this one, I came up with dynamic applications require IMU solutions.
Oh, I like it. Yeah, dynamic applications. After all, that's what we talked about. Everything we mentioned is dynamic, and IMU is the solution to that. Very good. Cory, as always, thank you very much for coming. Thank you very much for sharing your knowledge with us. And I think it's obvious that anybody out there who has a question about this, wants to know if this is the right sensor for their application, they can give us a call.
Exactly. And thank you for having me, and look forward to the next one.
Very good. Bye-bye, Cory. Take care.
We hope you enjoyed this episode of Pepperl+Fuchs Plugged In. Please subscribe to our channel and never miss hearing about the latest innovations in factory automation.